Hi. Thank you for being all here today and listening to our stories and other stories. We're going to talk a bit about the migration process that we did at Riskified from Postgres to CockroachDB. First of all, let's start with who we are and what we do. I'm Harel Safra. I'm a data platform engineering team lead at Riskified. My team manages all the online database, everything that relates to customers directly, to the analysis process, or to customer dashboards.
And I'm Yoav. I'm a senior data platform engineering. I'm 5 years at Riskified, 20 years in the data world. Started with mainframe and Adabas.
So we talked a bit about what we had, where we are, why we chose to do this migration, how we POC'd, what we tested, and how are we migrating and what we achieved. So first of all, a bit about Riskified. Riskified is a risk detection management company centered around e-commerce. Our main line of business is a chargeback guarantee process that centers around credit card fraud, where our customers, which are online retailers, will send traffic to us to be analyzed and decided on. And we have ancillary products related to that around account takeovers, around claims abuse, around other products that relate all to the fraud domain. Obviously, this means we have a lot of data. And this means we have a very robust data platform, starting from the online systems, where we have systems that interface directly with our customers and save and store their data inside Postgres, inside Cockroach, in Aerospike, in Elasticsearch, in Neo4j, and a lot of other databases that all have low latency and various access methods to provide the services that we need. From there, we stream data through CDC, mostly, but some through ETL, through Kafka and streaming platform into the offline storage. We're using Data Lake in the lakehouse above Delta tables, and Snowflake for our data warehouse. From there, there's a retrieval process. Systems will get data will get aggregated and stored and queried. It could be direct queries from analysts that query the raw data. It could be dashboarding, and in the bottom, data sometimes flows back from the offline systems back into the online systems to provide the pre-crunch data that you don't need to crunch the data on live. What issues did we have with Postgres? So first of all, we're using Postgres, and we have used Postgres. We're still using Postgres for the last 10 plus years. We started with RDS from Amazon and slowly migrated from RDS to Aurora. And the main topology that we have is a single writer server. Each Aurora cluster, each Postgres cluster has a single writer and multiple readers. Aurora can have up to 15 readers, but still a single writer. That means there's a de facto transaction limit on the writer. We found around 10,000, 15,000 transactions per second choke a writer, and it doesn't scale very well with server side. It means that if you scale up the writer, there's still a limitation around how many transactions you can process. And in Postgres, everything is a transaction. You read without opening an explicit transaction, a single select is a transaction. If it runs on the writer instance, it consumes the same transactions that actually limit the scaling. That means that we had to take our monolithic system, our big system, it's written in Ruby, and split it into different clusters. We had the initial cluster, and then we split orders out of it, and we split a queue table out of it, and we split the billing table out of it, just so we can scale the system up and support more traffic. This is annoying. It's annoying to manage. It's annoying to patch. It's annoying to manage. It's annoying to patch. You have to have all the systems in the same database version. And if you don't do that, this is what happens. This is from a load testing endeavor that we did. This is AWS Performance Insights. If you're aware, it's a performance metric tool, and you can't see it, so I zoomed in. This is the largest Aurora server that we had during the day. There may be larger today. It's a 32x large server, a big one. 1 terabyte of memory, 128 CPUs. And you can see that the traffic ramps up and up and up and up until the limit. And the wait event is IO exact sync, meaning transactions that are ended and committed. Or Postgres needs to flush that to the disk, and that wait event is what limits the amount of transactions that we can serve with a single server. So we did a POC, and we needed to scale up. We did a POC, and looked for different database solutions.
Yes, so we needed to find a way to scale up these writer issues. So we wanted to start to shop around new technologies, and first of all, you need to make some ground rules. So we have some test criteria that we thought of. For example, the first one, and the most important one, is the option to have least to none changes in the application at all, meaning it has to be a Postgres compatible. Then it needs to do what we actually want, scale out, right? Also have all the database functions like online upgrades and backups and DRPs. And then the installation, we need it to be easy to install and install automatically. We will show you later. Security. Riskified uses personal information. We have high standards of security. And performance. If it won't perform at least as much as Postgres, then we won't take it. So we started to shop around. I guess you all saw those competitors. They all have cluster transaction technologies. But only two have a Postgres compatible one, which was the most important one for us. We gave them both the same resources, the same time to have the POC, but Cockroach really ticked all our checkboxes correctly, and we chose it. And then we did a head-to-head test. We copied all the data from one of our production systems into Cockroach manually one time, and we scaled up a new database to have it one-to-one, and we used JMeter to actually bombard it with queries that we recorded from the production system. Most of our queries are transactional selects using a primary key. We have some updates and inserts. And in Postgres, it took about less than 1 millisecond, again, because it is a single writer, and it can perform all this much easier. While in Cockroach, it took about 3 milliseconds. A bit higher, but again, in a tolerable environment for us. And then we did a main application sample. We took an application on Ruby, and we scaled it to work on both servers. In Postgres, it took about 60 milliseconds, and in Cockroach, it took about 80 milliseconds, again, in a tolerable environment. And now we need to implement it in the structure, in our infrastructure.
So we have a long list of requirements that we want from all technologies and team-managed databases. So we'll drill down into databases. First of all, we'd like when a server is being decommissioned, we want to auto-replace it. We don't want to manage servers individually. We have hundreds of servers. We want to have the option to replace all nodes in the cluster in case Amazon release a new line of hardware. We want to migrate to that and enjoy that benefits. We want to have automatic deployments. We want to have automatic change management as much as GitOps as possible. We want to have rolling restarts for cases where we need to implement a new SSL certificate like we just did on Monday. We want to have monitoring, obviously. It's a database. We want to have backups. And we may miss that on the initial slide, but we really, really, really enjoy using CDC to capture data from online databases to offline. So we want the system to have CDC. First of the requirements are answered using auto-scaling groups from Amazon running on different availability zones in the same region. We aren't using multi-region yet, or maybe not. It's true that it allows more resiliency. It's much more complex to manage. It costs more, so we find that a single region is enough for us. We are using multiple availability zones inside the same region with a network load balancer, which is the blue squiggly thing on the top. Clients connect to the load balancer. The load balancer across all availability zones. And when a client connects to a CockroachDB server, it will create the data for them. That solves single server replacement. Auto-scaling group does that automatically. When a server is decommissioned, it spins up the new server. It also allows us to replace all nodes in the cluster by adding nodes to scalability to the ASG, having it rebalance, removing the old nodes, having it rebalance again, and then we're done with that. We do that with Cockroach. We do it with a lot of other technologies that we self-host in our cloud. For automatic deployments and change management, we use Terraform and Ansible on the servers. We start with GitHub Actions. GitHub Actions will run a Terraform plan. So you create a branch, you merge, open a pull request on the branch. It will plan automatically and show you the plan for other people to review. You can't just merge it automatically into production. That's a big no-no. And when it's reviewed, the PR is merged, and we run Terraform apply. In case a new server spins up, it will pull an install script from S3 and run an Ansible script on itself, basically, and add itself to a cluster. All this mechanism is based on tags. So Terraform tags the instance, and Ansible reads the tags that the instance has and knows which cluster it needs to join. That's a lot of the stories. Beware of that. We also like to manage objects inside the database with Terraform as much as possible. We started from a Postgres provider and forked it and added the CockroachDB support for Changefeeds and for other things that are not exactly 100% Postgres compatible. Roles that are valid until unlimited in Postgres are handled a bit differently in Cockroach, so there's a slight differences, and we've adapted that. Feel free to use it. We'd like people to use it. Rolling restarts are scheduled through Airflow using Ruby code. Yes, I know Ruby. It's not cool, but it works, and it's we like it very much. And monitoring and backup is based on the Prometheus, Grafana, nothing fancy here, and then the built-in console. We're using the built-in exporters. We're scheduling backups, both full and incremental, daily fulls and incrementals every hour. To S3, we do it both on the local region to support quick restores, and to a DR site where we ship data to US West, basically, to have the data over there, and in case of a regional disaster. How did you migrate?
So now we need to migrate. Everything was high talk, but now we need to do the actual work. So we need to copy the data. We have data in our Postgres, and we created the CockroachDB using the SGs and all the fancy stuff. But now you need to move the data. First, we need to create the schemas in the CockroachDB. So this one we did manually, created all the scripts, and now you need to copy the data. So we use the DMS, the AWS management migration system services, and we use it for the full load of the data and also the ongoing changes. It's called CDC. But we want to make sure that the migration will move smoothly as possible. And if in any case we will have any issue, we want to fall back as fast as we can. So we have another Postgres that we set up as a fallback, which is actually a replication, a clone of the production one. But we need to also give it the changes that are already in the CockroachDB. So we set up another replicator factor, which is called Replicator, the tool by Cockroach Labs. And it's going and moving all the data. We had some issues with partition tables on the Postgres side, but using custom scripts handed us by the professional services here, and we solved this issue also. So now, some migration tips. Let's start with the docs. Everything is written in the docs. So first of all, you can use the Cockroach Cloud Migration Tool. It is a free tool to use. Everyone has it. And we used it also to load first the schemas from our Postgres, and then we got the rejects from the tool, and the tool asked us what to change. And once we did it several times, we understood what we need to change, and we didn't use it anymore. the identity columns also in the documentations. Our application uses identity columns in the database. And this is not really best practice in CockroachDB because it can lead to hot shards, nodes that will be busier. So we changed the identity columns into a different function, a built-in function, which is called an ordered unique row ID, which is actually a big int, but it is not sorted. So we won't have any hot shards. And again, read the documentation, because you have a lot of things there that you might get hung up on. So as you maybe remember or not, we wanted minimal to no change in our application. So we wanted the migration to be as smooth as possible, and we don't want to change anything if it is not really necessary. So we use the same port as our Postgres. We have a load balancer, so we can mask any port we want. So we also use the port of Postgres. And also we use the DNS. The DNS is the same one as the Postgres is. So we just changed the DNS and and restarted all the pods in Kubernetes, and one by one they started up and now connected to the CockroachDB. They didn't know that something was changed even. Read committed transaction isolation. We started to work in Cockroach version 23. In version 23, the default transaction wasn't read committed. And this caused us a bit of issues with our Ruby-based application. So we changed this as a default. In version 24, it is a default transaction isolation, so you don't have any issues. And we also manage the schema changes within the application sometimes. So creating a table and doing an insert on a table on the same transaction is not possible in Cockroach. So we need to wrap each statement in a different transaction or explicit transaction. Changefeeds. So we use the Bezium, or we used to use the Bezium with Postgres. And the Bezium uses replication slots. But replication slots are not supported in Cockroach, so we can't use the Bezium. So we use the Changefeeds. And the message that the Changefeeds emits is a bit different in format than what the Bezium used to emit. But we managed to handle it also using our great engineering team. And actually, we don't need any Kafka Connect anymore, because the CDC, which is a built-in function in CockroachDB, doesn't need the Kafka Connect cluster. And we use Terraform automation in order to create the change feeds and also to create the external connection to a Kafka, because the change feed emits the data to Kafka, and then Kafka or other applications can take the data from the Kafka and send it to whatever they need. OK, so some lessons that we learned in a hard way, so you won't need to. So Ruby, our main application, our chargeback guarantee application is Ruby-based. And we like it. So, and it's actually Ruby on Rails, right? Because it is not really Ruby, which the programmers write the selects inside. It's actually Ruby creates the connection layer and the selects and the inserts into the database. So Ruby on Rails works with the Postgres adapter on Cockroach. Nothing changed there. Great. You might want to turn on the SSL flag. As you remember, we really need security, so the CockroachDB is encrypted. Also, Postgres was encrypted, but from some reason it didn't need the SSL flag, but Cockroach really demands it. Rake. Rake is a tool by Ruby on Rails that we use to manage the schemas. So this needed some adapting, basically because the Rake thinks that it is a Postgres, so it tries to use tools of Postgres. For example, PG dumps, which doesn't really exist. So we need to create DB migrate and the DB test prepare, which are both used to create the migrations, the schema migrations. They needed a bit of adapting using the kind type of CockroachDB support engineers. We managed to solve that also. Node and ORM type. Nothing really changed, just needed to create, to change the connection to BSSL. This is because we use global certificates. We actually don't use a node certificate. We actually use a global certificate to the entire system. So this was a bit of change, but Postgres really didn't need it, again, like the Ruby one. Scala and JDBC, well, just works. Just connect it, and that's it. All right, so let's wrap it up now. We had some scalability issues, some. And they were solved by CockroachDB. And we use AWS Auto-Scaling Group, ASGs, to manage the cluster. Our migration required minimal to no change on the application sides. And we replaced the Bezium with Changefeeds. Thank you for that. Any questions? Yeah. Yeah.
Hey, well, thank you for the presentation. Really interesting. The question is, what about price? Right? Because in Postgres, the instance that you were running, you didn't mention any like read replicas or any other instances. But for Cockroach, I don't know how many replicas you're using, but usually it's more expensive.
The standard topology we have with Aurora is a single writer. It's not here. You don't want to talk? It's a single writer and a single reader. So the Aurora topology has the storage. You pay for the storage. You have to pay for instances as they go, either provisioned or serverless. We use provisioned instances. So we have a writer and a reader. The reader is used both for high availability and for offloading reads. And you pay for the licenses basically inside the server price. So if you look at prices for EC2 and prices for Aurora, the Aurora prices from the same type of server will be higher because they basically bunch the licenses or the support inside. In case of Cockroach, you just buy EC2 servers, EBS, of course, from Amazon, and you get licenses from Cockroach. We found it to be about the same ballpark for our use case. Around the same area, a few $1,000s here or there, but around the same ballpark, even though you have to replicate the data 3 times on EBS and you don't have to replicate it on Aurora, it comes out that it's basically about the same. Yes, I see. Yes.
Well, yeah. but fine. Like I don't fully understand. Like with a single reader and writer for Aurora, it costs. But usually Aurora is like 6 times more expensive than a regular RDS, right? If I recall correctly. Maybe I'm wrong, but it requires more.
I'm trying to remember back because we did the RDS to Aurora migration about 3 years back. We found that we have a lot of data that we store for indefinitely, basically. We stored it indefinitely, and we take and because of that, we have a lot of price attached to the data storage and through IOPS writing it in Aurora. So that cancels out the storage IOPS part cancels out because you don't pay for that on EC2 and EBS. It's not on a per IO basis. So that cancels out. You have server prices going down. You have EBS prices going up a bit because if Aurora storage is 10 cents per gigabyte and GP3 is 8 cents per gigabyte, we have to multiply that by 3. So storage prices go up, IOPS go down, server prices go up, license goes up. Server prices go down, license go up. It comes out to about the same price. If you have a reader. If you have just a single writer, you'll probably pay a bit more in Cockroach, but I don't think anyone runs production with a single writer.
We actually have sometimes 2 or 3 readers with the writer. So it will be a 4-node server of a 16x large or 12x large, which is quite expensive. And sometimes We, on our busy days of Black Friday, and because we are e-commerce, we created even 2 readers of 22x large, which was quite expensive. Yeah.
So when you have this high traffic load, like Black Friday is coming, what do you do with Cockroach? Do you pre-scale? Do you?
Yeah, we'll pre-scale.
Yeah.
We find that scaling databases is not an online operation.
No.
We found we have Elasticsearch that behaves basically the same. We have Cockroach. When you provision a node, it has to copy data over until it starts to function as a viable member of a cluster. In Elasticsearch, for example, it has to copy all the data. Cockroach will start serving queries and move the data in the background, but it takes time, and during that time, it loads the cluster more. So for example, in case of Black Friday, we know in advance Black Friday will happen. It's a Friday at the end of November. It's very easy to predict. So we pre-scale that, the cluster for that. We have vague ideas about auto-scaling for load, but again, because during the high load, the auto-scaling, the scaling up loads the cluster even more, it's a bit iffy to do that. You need to do that well in advance just not to load the cluster with the rebalancing.
Okay, cool. And one more question, if you don't mind. You explained that when you started to hit limits with Postgres, you started to basically move data between clusters, right? Have you moved all that data back to a single cluster in going to Cockroach, or have you?
Yes.
Yes.
Okay,
thanks.
Actually, it's different databases, because when we created the different cluster, you need to create a different database name. So in this cluster, we have several databases, but actually, if we really, really want, we can create all of them on a single database.
But again, changing a database name is an application change. Needs a CI change, needs to be deployed. We wanted to have the migration just as a restart. So we have a single cluster, 6 databases inside of that. 60 terabytes in size.
Right. So, thank you for your time.
Thank you.
We'll be here.